Chapter 11, Identity of Einstein's coefficient with our elliptical coefficient. There exists, as we know from our own search and demonstration in the geometric field, an elliptical functional order ad infinitum contained in a relativistic train whose static physiognomy is negative b squared divided by a squared. It's the same form as negative v squared divided by c squared. What can be deduced from this formal identity of the two expressions? That both have the same static representation of the geometric shape of the elliptical fields. On the other hand, notice how b squared divided by a squared of our magnitude g is composed of an expression of variable and another a as the limit of this variation. It represents therefore a variable limit that depends on the physical state of the elliptical medium. That is, it has the same behavior as c in that this is also a variable limit that depends on the physical state of the medium. Both terms are, therefore, functions of the same chemical state, and both, because they have the same functional behavior, despite the fact that one is static and the other is dynamic, they cannot have more extension than that allowed by the magnitude of the place that contains them. It only seems that the a-axis cannot have any other numerical constant than the 3,000 kilometers that correspond to light. Therefore, a is substitutable for the relativistic unit par excellence, the 3,000 luminous kilometers. And since this number represents the limit of physical speeds, it then represents a part of this speed located in some way in the field. The rotation of the stars, for example. We focus on this fact because in the end it entails the natural rhythm allowed by the static time in which said star is contained. From here, we then have that it is either the astral period and at the regular limit of the maximum physical speed in the same elliptical space. But since this period cannot exceed the ordinary limit of any speed, it will be, let us repeat it once more, a equaling c, the speed of light, and b expresses, according to what has been explained, a part of c located on the material and effective mass of the field or space. B is therefore the velocity of the mass. Then our formula, negative b squared divided by a squared is equal to negative v squared divided by c squared. Now v is simply the tangential velocity at the distance of the cosmic radius of the mass. That is, there will be v squared equaling w squared v squared. And substituting, negative w squared divided by c squared equaling negative w squared r squared divided by c squared, 1/2 equaling negative w squared r squared divided by 2c squared. This formula has the advantage of being within the seismic process of nature, and for this reason, despite the formal identity, it excludes from itself the absurdity of Einstein's rotating disk. She represents the structure of G, or the potential of elliptical convexity. In these circumstances, w squared r squared divided by 2c squared represents work like a change in the static acceleration in the measure of v divided by 2c squared as the true law that contains the variation of the mass according to the place and the cosmic distance in question. This is a math problem, and then substituting it will be another math problem, where from this math problem, with all this, the identity of our elliptical coefficient with that of Einsteinian's relativity, ipso facto has demonstrated the absurdity or inconsistency of this coefficient of Einstein's, and demonstrated with the thought of the same genius, that is, the application of an elliptical coefficient to the negative universe of the hyperbolic type. As can be seen, the magnitude g, its shape, is the essential characteristic, or the coefficient of relativity for all the equivalences of the three-dimensional continuum within the ellipsoid type. The magnitude g is, therefore, the peculiar form given to us by the relativistic physiognomy of the spaces contained within that type. On the other hand, don't forget, said magnitude g depends on the geodesic lines already referred to. Reciprocally, if when finding a continuum and then determining its function, we find that the form g will conclude ipso facto that it is an ellipsoidal type, and nothing more than that type. Any deformation of g implies, therefore, a change in the similarity function.